So now we're going to talk about quartiles. If you remember when we talked about the median, if you have a set of scores, a set of data values, the median divides the data up into two equal parts, the bottom half and the top half. So half of your data values are below the median and the other half are above the median. Well, quartiles divide the data into four equal parts. So instead of having a bottom half and a top half, you have a bottom quarter and a lower middle quarter and an upper middle quarter and a top quarter. And so the dividing points, there are three of them, and we call them Q1 and Q2 and Q3. So those are the quartiles. And Q2 is the same as the median. So Q2 is right in between the bottom half, the bottom two quarters, and the top half, the top two quarters. But then you've also got Q1 that separates the bottom quarter from all the rest, and you've got Q3 that separates the top quarter from all the rest. So notice that Q1 here would be the median of the bottom half, and Q3 would be the median of the top half. So to find the quartiles, Q2 is the median of all the data. Q1 is the median of the bottom half of the data. So if you found the median of all the data, then just look at all the numbers that are below the median and find the median of those. And then look at all the numbers that are above the overall median, and Q3 would be the median of those. So to find the quartiles for a set of data like this, notice they are arranged in order from lowest to highest. So that should be the first thing you do if they aren't already like that. And now, first thing we need to do is find the median. We've done that before. We know how that works. The median is kind of the halfway point. Here there are 10 numbers in all. With an even number of values, the median is going to be between two of them. So in this case, it's right here between the bottom 5 and the top 5. So halfway between 83 and 84 would be 83.5. That's our median, and that is Q2. Now, if you just look at the numbers that are below the median, that would be these 5 numbers here. What's the median of those? Well, with 5 of them, that's an odd number of values. The median is the one that's right in the middle, which would be 82. You've got 2 numbers that are below 82 and 2 numbers that are above 82. So 82 is the median just of those 5 numbers, which means it's Q1 of the whole thing. So Q1 is the 82. And then for Q3, look at these 5 numbers that are above the median. What's the median of those? 86. So Q3 is 86. And I'll just mention that coming up in the next section, when we talk about box plots, those are going to be based on these 3 quartiles, together with the lowest and highest numbers of all the numbers. So we will be using these quartiles in the next section. But now let me talk about what outliers are. An outlier is a value that is extremely high or extremely low compared with the rest of the data. An outlier is a number that's a lot bigger or a lot smaller than all your other numbers. How much is a lot? Well, I'll try to answer that in a minute. But first, let me talk about how outliers might arise, what they might mean. They might just be mistakes. They might be the result of observational or experimental error, or they might be the result of like a typographical error, data that was mistyped or miswritten. So for example, let's say you're studying how fast the cars go on a particular stretch of highway. How fast are the vehicles that drive along that highway? So you go down to the highway with your radar gun or whatever you use to measure the speed of the vehicles going by, And every time somebody goes by, you see how fast they're going, and you write that down or you enter it into your laptop or whatever. And then later, when you're looking at the numbers you've written down, you've got 67, a 71, a 62, a 59, a 78, an 83, a 7, a 69, a 71, and then you say, hey, wait a minute, one of those numbers was a 7? That doesn't seem right. What's that 7 doing there? Well, maybe you made a typo when you were typing it into your computer, and it really was supposed to be not 7, but 70 something. 73 or 79 or maybe 67. Or maybe when you were using your radar gun, it malfunctioned and somehow gave you the wrong answer. Or maybe there actually was somebody going by at 7 miles per hour because they were on a bicycle or in a horse-drawn carriage or in a really slow-moving tractor or something like that. Or maybe a jogger. So maybe they really were not a mistake. Somebody really was going 7 miles per hour, but they're not the kind of thing that you were really thinking about when you were thinking of measuring the speed of the vehicles that were going by. So when you have outliers, what do you do about it? Well, if you know or strongly suspect that they're the result of an error, you made a mistake, if you know what the correct value should be, then go ahead and correct your error. If you know it's a mistake, but you don't know what the right number is, you should probably just throw out the erroneous data, not include those numbers. If they are legitimate values, but unusual, you might have to make a judgment call about whether they're the kind of thing you want to include in your study. Sometimes they are. Sometimes you do want to include those outliers, even if they are a lot bigger or smaller than all your other numbers. They're just part of your data. They're some of the things you're considering. But sometimes you might have to think, well, when I was talking vehicles, did I really want to include somebody on a bicycle or a Segway or something like that? So you have to be careful about, is this the kind of thing I'm really including in my study? So I said I'd talk about what counts as an outlier. How far above or below the rest of the data does a number have to be before it really counts as being an outlier? So here's one method that's used. The interquartile range is if you subtract Q3 minus Q1. In the last section, we said the range was the highest value minus the lowest value. So that's how far apart the biggest and smallest of all the values are. But the interquartile range is how far apart the two quartiles are, the Q3 and the Q1. So if you subtract those, Q3 minus Q1, and then an outlier is any value that's either smaller than Q1 minus 1.5 times the interquartile range, or it's larger than Q3 plus 1.5 times the interquartile range. So that means to be an outlier, you have to be below the first quartile by at least 1.5 times as much as the interquartile range, or you have to be above the third quartile by at least as much as 1.5 times the interquartile range. And when we talk about box plots in the next section, you'll be able to visualize that. So I will come back to this in the next section, and I'll be able to show you what this looks like. But in the example we were just looking at, we got that Q1 was 82 and Q3 was 86. So the interquartile range, Q3 minus Q1, would be 86 minus 82, which comes out to be 4. So that's a pretty small interquartile range. These two numbers aren't very far apart from one another. then 1.5 times that interquartile range, that would be 1.5 times 4, which is 6. 1.5 times 4 is 6. So if we start at Q1 and subtract 6, go down by 6, that takes us to 76. So anything below 76 would be an outlier. And then if we go to Q3 and add 6, 86 plus 6, we get 92. So anything above 92 would count as an outlier. So do you see any outliers? Well, yeah, that 35, that's definitely below Q1 minus 1.5 times IQR. It's more than 1.5 times the interquartile range below Q1. It's below 76 by a heck of a lot. So the 35 is an outlier. It is way below all these other data sets, all these other data values. That score of 35 was way lower than all the other scores that everybody else got on this test, for some reason. So I'm going to end this video here. We'll come back, and the next section is about exploratory data analysis. And the main thing we'll talk about there is, like I said, what's called a box plot, which is a way of visualizing some of the things we've been talking about here with the quartiles and the outliers and all that.